Hi everyone, I am Aritra and welcome to the demo of this full stack agentic task runner. So it's built in FastAPI and React. So this agent is parses the natural language tasks, scores and selects the most appropriate tool to execute that specific task and then returns a fully numbered execution trace. So for compound task, I have chained it across multiple tools sequentially for this application via a multi-step orchestrator, and it basically threads the output of each step onto the next. So I have provided a detailed README file with the GitHub repository where you can actually go through each of the steps, how to kind of load the application, run each of the front end and the back end, and then test out with different examples as well. So to give you a brief understanding of how the tool looks like. So first of all, when you open this in a Visual Studio or any other IDE, so if this is kind of the project structure with the backend and the front end one. So to load the backend, so what you need to do is go inside this CD backend folder, open a command prompt window. So I recommend like having two separate command prompt terminals open so that you launch the front end and the backend simultaneously to load the application. So once you go inside here, so what you need to do basically is you need to just do a pip install of all the requirement.txt file. So there are the different libraries in the requirement.txt file. So do a pip install that. And then you run the uvcorn app command. So that loads the backend at the port 8000. So if I show you here, so at 8000, and if you go to /docs, so give you kind of like the uh, so this is kind of gives you the Swagger API of the all the backend endpoints basically. So from here you can also test out each of the applications. So the course part hasn't been implemented, so you can actually use any of the endpoints to directly just test it out in the localhost. Now back into the code. So to launch the front end, so it's built in like a typical React. So you can just do a npm install. And with that, you just need to use the npm run dev command. So basically, it's built with the white configs. So with white, basically, when we design the config file, so what it has is like it will automatically the white proxies redirect the /API/calls from localhost 3000, this is the front end URL, to the localhost 8000 in the backend. So that will be automatically routing that. So our front end URL will be localhost 3000. So now if we go here in the front end, so this is how our front end user interface looks like. So I've given you the header with the Agentic Intelligent Task Runner. So this is kind of the API status. So if the backend is up and running, so it will give you API online status, as we see in the other, and the backend is now up. I've also provided you a history of the tasks that we can that's already been run in this tool already, and these are some of the examples of that. This is the task input window where you can actually pass a particular task, and then when you hit the run task, it will select an available tool from this window. So basically, as according to the requirement, I have implemented the calculator tool for the mathematical expressions, the weather mock tool, as well as the text processor tool. And one extra I have added is the base64 encode decoding logic tool as well here. And then the one for the fallback explainer tool. So that's actually does like the extra part of doing the retry logic. So if one particular tool fails, it will try to see if that particular task can be done with any other tool, or else it will send a error message that this task cannot be completed due to some kind of errors. So I provided you for each step with different examples how we can actually test out each of these tool logics and then see how it works. So the main part of the code has been in, so if you go here in the backend, so if you see here, agent part, so there is a controller. So that actually checks for the single step task, if the task can be completed with one tool, or if the task is chained across multi-step in a sequential way. So that way it will be computing those multitask as well. And orchestrator is our main or handling the multi-step orchestrator logic. So it actually detects the compound tasks, splits them into order subtasks, and executes them with the appropriate tool. So it has also the output injection logic. As you will see in the README file, I've detailed with an architecture diagram how the flow decision of the decision logic goes from the single step to the multi-step orchestration as well. And we have provided with a trace format where each subtask produces its own numbered trace as well. So that's kind of the basic structure of this. So if you also follow through with the README files, I've provided some basic examples which we can try out. So let's go into our tool and see how basically simple tasks work. So first of all, let's say we try out with a simple mathematical operation, 3 plus 5, and see what it does. So as you see, it's using the calculated tool, it's output 8, and you can see the execution trace of the task. So it first receives the task, analyzes the task to select the best tool. It found out that the numerical expression can be best done by the calculated tool, and then it returns the result. Similarly, for the text processor, let's say we want to just try out the case sensitivity. So we just let's say try changing like uppercase of hello world, for example. Let's see. You can see here it is now choosing the text processing task, and then it is doing the uppercase, and you can see the execution trace of that. And if you now go to the history tool, as you can see here, these particular tasks are updated in the list of the histories. So we have limited to the last 50 tasks. So as you can see here, the numbers is updated. So you can see the list of the tasks. And for the database part, I've used a simple SQLite database. So once it basically launch this application, so there will be a task.db that will be automatically created, and I have actually provided you with the details of that as well, so you don't need to set up anything specific for the database part. So if you have like something like a database explorer for SQLite, so you can actually load the database and see kind of the tasks, what are the data. So as you can see here, this is my database. So it has a task ID, that specific task that you run, the output of that particular task, if there are any errors. So this is some of the examples that I run in my database, which particular tools it used, and then the steps and the timestamp. So that's how you can actually see all your records in the database as well. And then when you run from the backend API endpoint, so you can also fetch any particular data reports. So you don't need any other specific uh, configurations done. So now let's say we try out with a multi-step task. So where for multi-step tasks, so what we can do is first we can let's say try out with the base 64 encoding. So let's say we do this one. We first do a base 64 encode of the hello, then count the characters of the result. So it's a two-step chain for a multitask orchestration. So as you can see here, it is using the base 64 encoding decoding tool and the text processing tool. So if you see the logs here, so you will find out, see, let's say, so once it is extracting the target here, it resulted this with 8 characters. And then for this particular output, it's counting the characters with the text processor tool, which is 8 characters. And it's outputting the 8 characters here. So that's kind of one of the simple ones. And then let's say we try with a 3-stage chaining logic. So let's say we try this one. For example, base 64 encode of this word hi, then we reverse this and then the result and then count the characters. So this is kind of a 3-step multi-chain. So when you run this particular task, as you can see here, it is using the base 64 and the text processor tools. So 4 characters, as you can see from the execution trace. So it is first encoding the word hi. And once it's encoded, it gives you this results 2 bytes and then 4 characters. Here it's your result. Now for this, it goes to the second stage. So it will reverse this. So it will reverse this particular encoded string of hi. And then it's reversed to this one. And now the next one is basically you're kind of counting the total number of characters. This is 4. So it is counting the characters and generating the output here. 4 characters. So that's kind of for the 3-step multi-task chaining. Now you can, I've also included one condition for like partial chaining. So let's say you have a weather. So you want to just do like a weather in Tokyo, and then you want to do like a uppercase of that particular condition. So let's say first we'll try with weather in Tokyo. So just to show you, so this is our mock weather interface. So I have created like a sample mock data for 20 cities weather. So it will have a condition, temperature, humidity, wind, etc. So now this is our basically return from the weather mock tool. So now let's say we try it with like uppercasing the condition. We also try to invoke the text processor tool here. So now when we run this, so as you can see here, it's kind of like a partial chaining. So it is uppercasing the condition clear here. So that's how basically this is working. So that's how we have actually provided with different kinds of uh, scenarios to test out for the multi-step orchestration. So it's simple one, so that it's easier for the users to interpret, as we are not using any kind of like LLMs here. So just that kind of like a sequential multi-step response. So that's how we have built the tasks. And if you go into the README file, you will also get like all the different details of like how each task can be tested with different examples. And also we have provided the basic structure of the multi-step responses as well, and along with the results. And to run the test results, so I have also like created the test file. So if you go here, all the different tests are part of this one. So you can actually use the command like pip install like a pytest, and then run using like the Python pytest test all files, and then you can actually run all the test cases for this one. So I've created test cases for all the different multi-step orchestration along with single step and every separate tools as well. So in terms of like the bonus features, as I mentioned earlier, so I've implemented the base 64 encoding decoding tool as well, along with the standard ones. So that's one of the base 64 tool has been incorporated. So I have also incorporated the multi-step orchestration that I was showing you. Uh, Along with that, there is also an option to containerize and using the Docker file. So I have showed you. So for example, this through the normal like the backend and the front end command prompt. So you can also use the Docker compose file. So this is the Docker configuration setup. So what you need to do is you don't need to for that to go to the base folder. So you can just go back to the root instead of backend, going to the backend and the front end folders. Go back to the like the agent system root folder, and from the root folder you can actually run this Docker compose command, and that will trigger you all the applications. So keep in mind, I have provided one like note for the Windows application is that whenever you're running the Docker command, just check for any stale environmental variables exist for the Docker. Otherwise, it might give you a path not found error. So fix that in the environmental variables and then run the Docker command to also do that. So that's an extra additional way of running this application. And in terms of the retry and the fallback logic, I have mentioned that here I have a fallback explainer tool as well. So basically, it will check for any kind of like an fallback error, and it will handle that gracefully. So for example, divide by zero error. So if we try to do one thing here, like 10 divided by zero. So if I run this particular task, so it cannot divide by zero because divide by zero is mathematical undefined. And then we are actually providing you with this fallback error, divide cannot divide by zero error for this one. So it actually tried to call the calculator tools, but since this is a divide by zero error, so it will give you like a fallback explainer tool also after calling the calculator tool that it cannot do the zero by division. So this is one like some of the use cases that we have done for error handling. There are many more scenarios. You can also try it out from the README file. You can actually see the other uh, scenarios for that, and then you can actually try it out and see that. So that's in brief how this application looks like. Of course, because of the time constraints and like the scope of this particular task, there are a lot of ways we can actually like improve this, but like this is kind of doing all the basic functionalities and also including the bonus features that were asked in the task requirements. So I've incorporated most of them as requested. So yeah, let me know if you face any issues. Definitely, I will try to give the more demonstrations in the main meeting. So thanks everyone. Thanks for listening to this. Bye bye.